Just a quick note for all animation videos that you're going to be watching is that the software that captures the video actually captures at a frame rate of 10 frames per second. So it's going to look choppy no matter what in these videos, but once you actually run it in your program, you're going to find that things move a lot smoother and cleaner. Thanks for listening. So at this point we have a running man running on a still background with a mushroom floating in the background. What we're going to look at now is a common feature in classical games called a scrolling screen. And basically what's going to happen is we're going to make the screen, the background itself, move behind all of the elements of our game. So we're going to, in our case, we're going to make it move from right to left. And what's going to happen is, right now it just looks like our character's just kind of running on the spot, not getting anywhere. But if we start moving that background in a right to left progress, it's going to look like that character's actually running and moving on a surface, as long as we can get the timing right. And sometimes that's a trick in itself. But for now, we got to figure out how we can actually move that background and how that technique works. So you see this screen, just got a basic brick floor, some data at the top, and everything else we're adding in there extra. So what I'm going to do is I'm going to show you how we're going to manipulate this. And it's a very simple concept, and it doesn't take much code at all to actually do, but you do need to understand how it works. So basically, where's my pencil here? There we go. What we're going to see, like our screens basically, oh my goodness. There we go. Put that back on here. Our screens look like a rectangle. That's a beautiful rectangle, by the way. And this is our top corner, which is set at 0, 0. And over here, we know that this is the screen width, which we can get by gc.get screen width. Oops. And a y value of 0. Now basically the way that our scrolling screen works is we have a background and we had some text here, some text here, some text here, and some text here. The way that a scrolling screen works is it's going to move the screen, and when it gets off the screen it's going to bounce back and start going through again. But the problem is, as this one moves, that means we would have like a gap, an empty space behind it. So what we need to do is we need to create a duplicate of that screen that starts off screen, completely to the right of the screen, or the direction that our scrolling is coming from. And it's going to be drawn the same height, the same width, the same height in that location, same y value, but its x value is going to be right here. It's going to start at the width of the screen. Let's subprogram. Now the trick though is that to make sure that it looks seamless is that both backgrounds need to be identical at the left and right, which means if you have, let's say for example, a little tree here that kind of moves across like that, it needs to be finished on the other screen. So we see that, and maybe we see the end of the trunk, which means over here we would see the exact same thing. See if I can get this relatively close. So where it starts, it ends, so it looks seamless. Now we don't have any complicated objects in our example, but we do have brickwork, and that brickwork does have seams in it, so those seams should match up. So what's going to happen is both of these screens, which are drawn at all times, so let's call this BG1 and BG2, they're both going to move from right to left. So the x is going to go, basically we're going to say x is equal to x minus scroll speed, whatever our scroll speed is, how many pixels per update. Now the trick though is whenever one of these screens, whichever one, gets fully off the screen, which means its y value is still 0, but its x value is negative screen width. It's one full screen width off the screen. So when that occurs, what we want to do is we want to bring it back to the right. So what we end up with is a pattern that looks like this. Move back. move back. And it creates like a conveyor belt of background images. A continual loop of these two images. They're always just kind of following one another. And it's going to go forever. And as long as the artwork is seamless, it should look perfect on our screens. So we're going to do this in a few steps in our program just to show how this works. So over here, first thing we're going to do is let's make the original background move from right to left. All we have to do that is follow the same directions we did with the mushroom. We're going to say bgimage.destrec.x is equal to bgimage.destrec.x minus, let's say, 2, for example. So that's going to move it 2 pixels to the left every single update. Now if we run our program, we see it actually moving. But since there's nothing following it, we get just the black background behind it. So it's not terribly helpful to us at this point. Also, we're using this magic number of 2. That's never a good thing. So let's go up to the top and create another variable called int scroll speed. Now again, just like we did with the x speed and y speed, we can make this a float and we can be tracking that stuff, and we can make it move by a partial pixel if we really wanted to, but that's depending on how fast you want your screen to actually move at. But for now, we're going to make it move by scroll speed, and we're going to start that out at a value of 2. So instead of subtracting 2 down here in the update, we're going to subtract scroll speed. So then all we have to do to modify our speed is just change that variable. What that allows us to do is change the scrolling speed in mid-game. So after a certain amount of time, maybe the game speeds up, which means scroll speed increases. Or maybe you pick up a power-up that slows the game down and makes it easier to control, so you change scroll speed to a lower number. Very easy to do, and then you would never have to change this code. All you have to do is change the value of that variable. So this works for one screen, but now we need to add a second screen. So what we're going to do is we're going to create another screenshot. And I don't know why I keep calling it a screenshot. It's a sprite sheet. Another sprite sheet that's exactly the same as bgimage. We'll call this one bgimage2 just to keep things simple. And it needs its own destrec, but it's going to have the exact same destrec as bgimage, with the exception that it is going to be over at its x value is going to be the same thing as gc.getWidth. There we go. Its y value is still going to be at 0. And my mistake, we actually still need to load the image in, but since it's the exact same image, we can just copy and paste that 100%. So it's the exact same image, it's the exact same destrec, except it's moved to the right side of the screen. Now all we have to do is make sure that we're drawing both of them. bgimage2, and we need to be moving both of them. So I need to duplicate my move code, which is inside of update, which we did right here. Copy and paste this. You notice how most of it's copy and paste, because all we're doing is doing the exact same thing to both things at all times. It's very parallel. So now if we ran it, what we're going to end up with is a scrolling screen that is seamless, but the problem is it still has an end. And that's because we haven't done the last step of creating the conveyor belt. We haven't looped it back. So we have to do that check to see, has it gone off screen yet? Well, that's easy enough to do. If bgimage.destrec.x is less than or equal to, and I am saying less than or equal to because depending on your scroll speed, it may not exactly equal to gc.getWidth. It may not exactly equal to negative gc.getWidth, and you may go past it a little bit. So that's why we use less than or equal to. When this occurs, we're going to move it back to the right side of the screen. So bgimage.destrec.x is going to be equal to gc.getWidth. So we move it to the right side of the screen and off the screen. And now we just need to duplicate this again for bgimage2. No, it is not an else if. It could be an else if, because it is only ever going to be one at a time. So that would be a slight improvement, but not too much. And we just need to change this one to bgimage2 as well. Now in theory, we should get an endlessly cycling background. Now it's still moving too slow to make it look like it matches our runner, so we got to play with those numbers a little bit. It looks like the runner's moving too fast for that speed, but it is endlessly going. So let's go play with our scroll speed, see if we can get it to match up. So right now it's at 2. Let's put it at 5. Run our program. That's actually quite a bit better. It may still be a little slow, but we're getting closer. You notice the mushroom is still moving at its own pace. But it does look like our character is actually running on the background. Let's move it. Let's set it to 10. Now that is more like it. That looks like he's actually running on the background. So we can create a nice running game using this technique. So that's how scrolling screens work. Just have to move them over and loop them back.